Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back. My name is Paul Webb. I'm the founder of B2B Energy, and I'm also your host. We'd like to thank our sponsors today, B2B Energy and Clean Energy Revolution. And if you want to know more about Clean Energy Revolution, please go on to any social media and type hashtag Clean Energy Revolution. Energy Speaks Back interviews energy experts from around the world. Welcome to our summer series and episode 40 of Energy Speaks Back. We would like to thank Esther Energy today for joining us as our partners. Weekly, I present to you experts from around the world, and today we are in Denver, USA. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. My guest today specializes in business process outsourcing regarding solar permits and engineering. So without any further ado, I give you Anthony Gianfrancesco. Good afternoon, Anthony. How are you today?
Good morning, Paul. I'm doing well.
It's good morning to you, Anthony. It's good to see you again.
Yeah.
So Anthony, we've met through our social media networks, but we've had quite a few one-to-ones, and we've had many a chat about football and sport, because both our teams, different sports, but we both wear the same colors.
Yeah, it's true.
Claret and blue.
Rapids out here in Colorado. I've actually seen a few West Ham fans, a couple of what is it, the Hammers? Is it two Hammers?
That's right.
Yeah, I've seen a couple of Hammer tattoos out here, and people supporting the Rapids. Wearing West Ham jerseys, like, you can't really tell.
If we was in England now, they say that they're the two supporters. That's what they'd be saying now. So, Anthony, what's the weather currently at the moment? We've got a beautiful day in England.
Just like most days in Colorado, it's really sunny. I guess we've been having a really rainy season. Colorado's a higher altitude place. It's great for solar because there's less air mass. So the sun rays don't get deflected as much, and so you get a little bit more sun exposure out here. You also burn a little bit more easy if you're white skinned like me. But yeah, it's getting a little hotter now. A lot of green out there because there's been a lot of water.
Right.
It's not drought like it is in California right now.
Brilliant.
I think we're stealing all the rain.
You're stealing all the rain.
I think so. It's got to go somewhere, right?
No, we've been having some serious rain recently. So I think it's across the world as well. So, Anthony, we've met, as I say, we've had quite a few Zoom calls, and we're part of the Clean Energy Revolution group, and we do exchange quite a lot of information. So I've learned a lot about you over the last 12 months. So for the benefit of our listeners today, it'd be great to hear your background story and, what brings you to the energy sector.
Yeah, I was born in a small village in Moldova. No, I'm just kidding. Yeah, we can go back to where I learned about solar cells.
You go back to where you need to go back to. We've got plenty of time. We can always edit it afterwards.
Yeah, no worries. So I started my soiree into PV modules when I was doing a research internship at the National Institute of Standards and Technology in Gaithersburg, Maryland. I was working on a project where we're putting these things called quantum dots on solar cells to see how we could make those quantum dots interact with the solar cell surface. Basically, a quantum dot is something that's like 10 nanometers big, and we were trying to excite individual quantum dots to image the surface of a solar cell to see solar cell grains. So if you look at a polycrystalline silicon cell up close, it's like a bunch of chunks together. Right. Those quantum dots were much smaller than those chunks. And so what we were trying to do was examine those polycrystalline silicon chunks to see if we could understand more. It was a novel measurement method at the time. Really cool project. And then I also was working on cadmium telluride cells. Most of the industry right now is polycrystalline silicon. There is one company, maybe more, but one bigger company called First Solar in the United States that does cadmium telluride cells. And so I did some research on those, and it was really cool stuff. Then I went off to grad school, to do more stuff in material science, physics, electron microscopy, looking even smaller than nanometers at the surfaces and structures. So I was doing some research on oxides, novel oxide materials. And so if you look at the current research, perovskite crystal class is the new type of solar cell that is trying to come out. And I was working on that similar structure, a couple of other structures too. But really just trying to look at how do the atoms come together, make electricity, how do they talk to each other, what do they say, how do they say it? Is it a lot of middle fingers or is it a lot of like handshakes kind of thing? And how far they interact. But yeah, it was a lot of really nerdy science stuff, a lot of really cool million dollar tools unique to our lab. Really, really cool stuff. But eventually I kind of decided I wanted to make a little bit of a different impact on the world, and I quit that program and took a job as a designer at Sunrun. Worked there for 5 years, was laid off due to COVID, and pivoted into doing something very similar to my job role, managing an outsource relationship with solar companies to the contractors they work with.
Right.
The solar industry is really interesting because you can do whatever you want in it. If you just want to sell solar, you can just sell solar and have somebody build it and finance it and do everything else. If you just like doing the designs, you can just do the designs. You find somebody to sell systems for you, do the designs, and find somebody to build it, or you can just build it. That's how a lot of smaller roofing companies are getting into it right now. They use their expertise of putting shingles on a roof to saying, we put shingles on the roof and we make sure roofs don't leak. Why don't we just put those solar panels on too, and then make sure the solar panels don't leak as well? And then they probably need help with some sales. But if you're doing roofing, you already have a successful business. How hard would it be to say, how about we slap some solar on there as well today? We're already doing the re-roof anyways. We'll make sure it's done really right, really well. Somebody you trust. And so that's what I've been seeing a lot with the solar industry recently, is a lot of new players coming in from different industries, because the skills are very transferable.
Yeah.
But yeah, so that's where I am today, is helping companies with their outsourcing, helping those relationships get better, closer, more exact, defining those relationships better, keeping people accountable. In fact, my company has 5 values that I hold near and dear to me.
Tell me, are we talking commercial? Or are we talking residential regarding this solar?
I'm talking about residential. That's where all of my experience is right now. I have been working since I was laid off last year. I've been working on commercial projects here and there, helping people out. But when it comes to the big scale, big volume stuff, it's mostly residential. The residential industry is really unique because everybody's trying to get lower cost as quickly as possible, lower cost and faster turnarounds, because some people think the only way you can make money in the residential industry is by doing things really quickly in a large scale. I don't necessarily think that's the truth. And I think that some people have a warped view of the industry. And I think they put a lot of that pressure on the customer to kind of like pay what they want to make. But maybe I'll leave it at that, because that probably is going to be a controversial topic.
Let's go back to when you was doing your research and the analysis there, because I'm intrigued to why we was looking at all these different materials regarding and how they worked. What was the end game there? What were we trying to achieve?
When I was working on those materials that really didn't do anything, we were funded by something called the Basic Energy Science Grant or something along that lines. And really it, to some degree, and it's for those people I worked with, I apologize if you're watching this, but it's basically science for the sake of doing science. You never know what you're going to discover. And so in the lab, we were blasting a crystal plate, a plate full of powder or a solid, with a laser. And then that laser would explode that target. And then we would have a substrate up here. And then basically you would blast material onto a substrate, hoping it sticks, hoping you put the right oxygen content, hoping it's at the right pressure. And then eventually a crystal will form. A lot of the times we were making crystals that were really a bunch of stuff stuck together. But other times when we had the right chemistry and the right composition and pressure, we'd have a crystal. Once you get a crystal, then you can start looking at how the electrons interact with those atoms that are in the crystal. So if you look at a perovskite structure, you've got 3 or 4 different atoms in there. Some of the atoms are really simple because they're smaller, SPDF shells, going back to chemistry in high school. When you get to those D and F orbitals, those electrons start to grab people like next nearest neighbors and next nearest neighbors, and they start interacting on a scale that modern computers really don't understand. So you really start to reach your limit of understanding very quickly. So you have people who study the theory, and then you have people who do the experiments, and bringing those two things together is near impossible. Because the current techniques and the methods that were developed, like when you go to grad school and you look at all the equations, it's like it would take with our current computational power, it would take the time of the universe to complete some of these equations. Right. The group I was working in was doing some stuff with data analysis and new novel methods to look at the data that summarized things quickly on a local scale to try to generalize it for the whole system, if that makes sense. So just doing the calculations in a different way to try to overcome our computational limitations of our time.
Yeah. So being a non-academic in this industry, what we're talking about here, are you trying to find new materials that are more cost effective?
No, it's just new materials because we don't understand how a lot of this stuff works.
Right.
It exists, but it exists and we can reproduce it in a lab, but we still don't understand it. And so the idea is to make new things, hoping that we can get more data and bring that data together. The idea is to figure out new crystals to create, because we don't know what they can do. They'll probably never exist in the real world. They'll probably, I don't know, I always joked, and this is kind of one of the reasons why I wanted to leave the field, was because I thought that maybe in 1,000 years, some paper I wrote or got published on would be like a toy for a child in like 1,000 or 2,000 years or something like that. You really don't know, or it could be a deadly device.
Yeah.
Like it happened with Einstein, right? But yeah, you really don't know what your effect is. You're just creating the science and creating new knowledge whenever you can, however you can, with the expertise, the knowledge, the tools you have today. And we need that type of research. We need those type of people out there just investigating and finding new things because they're new, because they don't exist, because somebody said they were impossible. Yeah. There is great value in having that. It's just not as flashy as an electric car. It's not as flashy as a solar cell producing energy. It's not as flashy as saving $50 to $100 on your energy bill each month.
Yeah. So based on your knowledge of your past, do you, and then bringing it into the future, do you think there's changes that we're going to be witnessing long term with solar? Has solar got a shelf life? Is it going to be made better in different ways?
Yeah, I can't really answer that at the moment. I think that there are things like superconductors that we've been chasing for 80 years. Is it 80 years? 70 years now? 60, 70 years. We make small progress in that year over year, but nothing really tangible. You always see articles every now and then that say, oh, this could be it, this could be it, but it's always could be. It never, this is it. Yeah. I think solar cells are a great thing for now. I mean, they do what we need them to do right now. I don't know if they'll be there forever. It's just a magical crystal that makes electricity when the sun excites it. And that's pretty much, yeah, it's basically a magical crystal that we luckily found, luckily created. And I think that we'll have something more complicated coming soon. Yeah. I don't know soon, but something.
So one day in the near future, we could find someone's created a paint where we can paint the building.
Yeah, I personally think that solar is it seems like it's almost seems prehistoric. It's like stone tools, you know. It's just a basic crystal that produces energy, and I think that there are ways that we can make it fancier, cooler, smarter, more efficient, and it all exists. It's just you can't beat the price of polycrystalline silicon. You can't beat the infrastructure we've built for it. the manufacturing techniques. It's all kind of just making it the king.
How can we make it more sustainable regarding, when it's gone past its life cycle? How can we make it more renewable in that format? Because I hear a lot of stories about it's not sustainable going forward. How do we get rid of it when it's failed?
I think there's a company in Australia, or the Australian, something with Australia and recycling. I recently saw in the news. They're starting a huge program on recycling these solar panels. Right now, it's just so cheap to make them that refabricating them doesn't really make sense, because it's just cheaper to make new. It's like plastic almost. There's enough sand on the earth to make, that's how silicon solar cells are basically made, is sand, silica. That's one of the key ingredients, and we have enough of that on the earth. The precious metals, on the other hand, are harder to find, create, can run into some ethical issues with that. But I think to make them more sustainable, it's really more about making sure we have a recycling program, giving some sort of incentive to even recycle them in the first place. And interestingly enough, I'm going to be hosting an event soon. I'm not sure when this is going to get published, but I'll be hosting an event soon with someone in the United States who works for a refabrication company in the United States, and they're going to be presenting a topic in another group, in a networking group that I run.
Right.
And that'll be really cool. I'll probably learn a lot from that on this exact question.
So what are the challenges at the moment regarding solar on rooftops in the domestic world?
I think that a lot of people see it as ugly. I think if personally, and I know I'm like shooting myself in the foot, but I think personally, if you're the only house in the neighborhood with solar on your roof, it does kind of look ugly. It starts to look better when it's a more conformed thing and you have more people on your block with it. That's my personal opinion. I know some people scream at me saying, no, they're the most beautiful thing on the earth. That's your opinion. I think the solar tiles are going to help fix that. I think that in addition to those two things, from what I've been hearing from people, I think people don't really understand the solar process in totality. I think that they rely on salespeople coming to their door to give them the information, and it's always whatever information helps close the deal, and it's not the information to teach them and educate them about solar. There are a lot of people out there that agree with me. There's a lot of solar YouTube channels out there. I'm thinking of making my own as well. Just hopefully adding a lot more jokes in to keep people entertained, because it can be boring. But yeah, I think the education piece and knowing the process of solar, being educated on what it takes, being educated on the local laws. To me, it's not difficult, but that's because I do this every day. I think that is possibly the biggest limitation. People don't know what the materials cost. They don't know where to buy the materials. It just seems like a black box. Somebody comes to your door and gives you a PPA where you pay per amp of production, and you're just like, okay, that's cool. I don't want to think about it. But I think that learning more before going into it would be a really good idea, especially for individuals trying to go solar.
How far do you go regarding the tariffs? In the UK, we have a thing called feed-in tariff. How do you go far? Because in America, I know each different state has the different, we were talking to Nico the other day on Clubhouse. It was going over my head a little bit regarding the different structures regarding how you fund it or as a user.
Yeah, in the United States, the government doesn't directly play any role in that. The utility, you negotiate a deal with your utility company. Your utility company provides you the power. You have National Grid, which is literally a national grid. The National Grid in the United States, which is the same company as from what I've heard, they're only in New England and only in some parts of New England. And National Grid, I think, acquired some utility companies and represents them, but the utility company still operates as its own. It's a very, very messy system. But you work and you negotiate with your utility company to see what they want to pay you for energy going back on the grid. That infamous duck curve, where there's no demand on the grid for noon because all the solar is giving into the grid, and then at 5 o'clock when the sun sets and there's a massive surge of demand because all the solar goes offline. I mean, that's something that the reason why those feed-in tariffs exist. That's the reason why these rebates exist. That's why a lot of places like Hawaii are on zero export. You cannot export back onto the grid because there's so many solar houses in Hawaii, because diesel's so expensive. It was profitable for people in Hawaii to go solar a long time ago. I think that those are the kinds of things that make the utilities a little sketchy on wanting to give you any money at all. It's you get pennies. I did something for the public utility of New Mexico for a person I was working with. And it's something like he has to pay 30 cents a kilowatt hour, and then they'll give him like 6 cents back a kilowatt hour if he feeds it in. And it's almost nothing. It's almost the fee to even apply for the program is $250. And over 20 years, he was going to be generating like $320. And if he didn't go into that program, he'd pay $50. So like just barely, it's not worth it. It's totally a crap system. The way people make their money on solar is from the federal tax incentives, where you get credit on your income tax. All the money you spent on solar, it gets deducted from your total income. The problem is if you're on retirement or you run your own business and you purposely don't have income because you're putting money into your business, it doesn't necessarily help you that much. And so you really just save money on the energy costs if you're in a place that charges a lot for energy, like California, unlike Texas, who doesn't really charge a lot for solar. I mean, for electricity.
Taking it to the next level, we've got batteries. So do you get involved with batteries? Is batteries you said that?
Yeah, I mean, batteries are a huge component. Yeah, and that's exactly what you were just saying. They alleviate that massive spike in the duck curve. That is going to be the secret. I just don't know if we have enough lithium in the world to create enough batteries to alleviate it for everybody. Yeah. I think that we are going to run into a lot of issues with EVs on top of home battery systems. I think that's what's required. But when we go back to energy, I mean, science for science sake, that's a really good reason to why you want to see more research into different storage systems, into different chemistries for battery that don't rely on lithium. It's just right now, lithium's really good at donating and accepting electrons from its orbital shell. We're trying to find new technologies every day. But research can be slow sometimes if there's not enough money in it.
And how far advanced is batteries in the States at the moment?
I don't have a great answer for you because I'm not staying on top of research anymore. That wasn't even my really topic of research when I was in grad school.
So all these solar projects you're doing at the moment, designing, etc. Is there any associated battery links with those? Is there a percentage that you could probably put in as a figure to say, well, 50%?
Maybe like 20 or 30% of what I see is batteries. A lot of the DIY people I work with right now, the people who build their own systems, have not so far looked at batteries. If I ever talk to somebody about batteries, they're trying to completely go off grid. There's nobody that's kind of like in the middle there right now. It's really just a matter of finding the right person. But right now, it's either they want to completely go off grid from what I've seen, or they just want the PV system to offset the bill. Yeah.
So this week I'm broadcasting AJ Perkins, the microgrid. Do you get involved with microgrids?
I have not, and I think that guy's doing some really cool stuff with his company. I've been reading his white papers. I've definitely subscribed to his newsletter. Yeah, and it's really, really interesting stuff. I think that it's a great concept, and I think it's going to help a lot of people, generally speaking. I just don't know how they are fighting or working with utility companies right now. I think in general, the idea is incredible. Imagine if we could use our substations that we have all over the place in the United States as smart devices to exchange electricity between houses, or have a supplementary solar plant just for that substation in that community. I think that that's a great idea. Unfortunately, what you see with solar in the United States, at least, is policy gets in the way. Public policy, utility companies fighting, lobbyists fighting. And so I know the largest solar companies out there right now are putting a ton of effort into fighting policies. Things like the California net metering, the new net metering bill in California, as we were talking about, it was going to hurt solar really bad. A lot of solar companies had to put their energy into fighting that bill because that was the threat. Now, instead of let's make a sustainable policy that grows with the new landscape of energy, like that doesn't happen. It's how do we fight the things now that are going to put us out of business so we can't even operate in 10 years? If solar companies lose California, you lose like 30% of your business right now.
What about ground systems? So when you've got them all in the ground in fields, is there many of those in the States?
In more rural areas, you have the space to do it. I'll be building one for a family friend. I'm not building it personally, but I'll be working with a family friend of mine personally in Rhode Island. He wants to put one up, but they're saying he has to have a fence around it. His local housing authority is saying he's got to have a fence around it with high voltage signs, and it's going to make his yard kind of look ugly. And I'm really upset about that because that's what you run into with HOAs, housing authorities, is they will limit what you can and can't do for the reason of they just like it or they dislike it. So if you have a small house in a suburb, or any house in a suburb that's next to other people, you most likely won't put a ground mounted system in because it just would look ugly or your HOA wouldn't like it. So you go on the rooftop. So usually those ground mount systems are reserved for people with more land. Maybe I'm going to throw a random number, 20 acres or above. I don't know if that works for you. If that's an American.
Yeah, it does. No, acres is good for me. And then obviously then you're relying on the connections, the availability of getting a connection back into the grid, which is then important. Unless you're putting it back into the building.
Yeah, there's sort of ways around it, but yeah, eventually you have to deal with a utility company. And that's where the applications come in. That's where a lot of the paperwork comes in. And the idea is that you size it and then the utility company will give you credits that you can use later. So, you're going to generate more electricity in the summer than in the winter. And you get credits in the summer that you can use in the winter to help offset.
So the work you're carrying out, does it migrate across the globe? Are you doing other
I'd like
countries?
it to. I'd like it to. I'd like to work in Canada. I can't imagine electricity is much different anywhere around the world. However, I think that if I was to be working in other countries, it might be better suited to be working on bigger projects. Yeah, I think the legislation is something I learned over my time as a designer for the United States. I can't imagine Canada being much different. But in the UK, I mean, I have no idea what necessarily, or Italy or France, like what the local government looks like, what that structure looks like, who to call. But I mean, that's definitely something I'd be willing to work with, willing to talk to about. I mean, I don't really say no to many things. Right.
I've got a few names I can probably put you in contact with, obviously in the UK.
Yeah.
It's not my expertise. Solar. I will recommend it. I don't get involved with the real detail on that side of it. I know that we rely on connections, and I look at the return on investments and look at the existing profiles of buildings to implement that on.
Yeah.
But that's as far as I go regarding it.
I think
I'll bring experts in.
It's really useful for demand. If you have peak demand at noon and the sun's out at noon, go for it. But I think that's where a lot of people end up spending money is demand charges when they get taxed heavily for using a lot of energy in a short amount of time.
Yeah. So, Anthony, it's come to that time in my podcast where I like to put my guests on the spot and ask them a specific question. And I'm sure you've been listening to my podcast. So is there anything you can give back to the industry today as a takeaway to our listeners?
Yeah, it's related to that point about educating people. I think that you can never really go wrong with educating people on what their options are, how things work. I know you do that a lot with reducing energy consumption, and that's the that's why we're friends, I think, is because we have very similar values and we're aligned in the way that we want to make sure that people understand as much as they want to understand. We educate people. We have that sort of integrity that makes sure people understand they're getting the best thing that's for them, instead of pushing a product that may be better for us as a company and not as good for them. Like that's not what I want to do. So I guess to summarize it is operate within your integrity, operate with the values that you hold close to your heart, and you can never really go wrong.
That's brilliant. That's exactly my thoughts. And we talked about core values. One of my core values is profit with integrity. And as long as I know that I've done the right thing by my client and my customer and the organization, I'm comfortable with the integrity that I will put. There's another saying that someone said to me once before, profit isn't a bad word. And as long as you've got integrity with it, you can't go wrong. And that's And my training, I love training people and giving education to the industry. I wish I could do more on a wider section, but this is why I do this. The podcast is because I bring experts in who've got that technical capability to give that learning, and that's what this podcast is all about: is giving education to other people around the world. So, Anthony, it's great catching up with you. We'll have a podcast dedicated to sport next time. We'll have more of a banter. We'll talk about the hammers in more detail. So, Anthony, thanks for coming along today. You and your family, be safe in these times.
Thank you. Thank you for the time today, Paul.
Thank you. Thank you for our special guest today. And thank you for our sponsors, B2B Energy, which can be found at b2benergy.co.uk, and Clean Energy Revolution, which can also be found either through various different social media networks. Type in #Clean Energy Revolution. That leaves me with one more thing to say. Be safe.